Uh, we're doing okay. I'm keeping up with it.
Okie doke.
So, hello and thank you to everybody joining us. I see a lot of familiar names, and we're looking forward to a good exchange with you today. Um, Ginger Hansel is going to do the presentation, and my job is to interrupt every now and then. But she'll be, you'll be in good hands with Ginger. And as most of you know, Ginger is one of the few people that has been president of the ESD Association twice. She did such a great job the first time, they had her come back and do it again. And I've been president, but not two times like her.
Mhm. I may be a
Um,
I may be a slow learner.
I don't think that's the case, but maybe. So we've got a good slide set today, and we're going to, as time permits, we're going to include discussion about some practical considerations that we've all learned the hard way. There are many subtleties that are not necessarily obvious, and we'll cover them as time permits. And let's see. Again, I think all of you know us, so I'm not going to really do much of an introduction here, except to reemphasize that we provide strictly professional services. We don't sell products, so that we can give you objective recommendations um, for whatever you might need for your program. And as you can see from the slide here, we've had some really interesting places and some great engagements all over the world. I'll just mention the one down in Australia. That was quite a trip and very interesting. And while I was there, I actually got to sail a 33-foot sloop in Sydney Harbor.
I
And
would like to mention the one in Alaska in February because
Oh, yeah.
the cold snap that everyone's been experiencing, it was minus 40, I believe. It was quite different. They
okay,
do have ESD issues in the cold up there.
what was that?
Yeah,
Okay.
Ted, perhaps we should mute people and they can unmute if they have a question, or they can put it in the chat
Yeah,
because there
yeah,
could be
I'll do that
background
now,
noise.
and I'll do that now and unmute you, of course.
No,
And
oh, okay, so I don't have to do this.
let's go here.
Okay, I'm back. Um, I assume somebody can hear me. So, as Ted said, we don't sell products, we only sell professional services. And the today the class is to focus on an ESD workstation, how to set it up, things to think about, and guidelines, and how to select and test a workstation. These are the documents, the current documents from the ESD Association that cover work surfaces, and so they're available. And 4.1 is for work surfaces, 6.1 is grounding, and 2020 is a basis for an ESD control program. And TR 53 is a technical report 53, which is how to do the various measurements for compliance verification. STM stands for standard test method, and S is standard.
Ginger, one thing we forgot to mention in terms of logistics, feel free to use the chat to ask questions, and we'll pass them on to Ginger.
Okay, first, what is an ESD control workstation? And it's an area that's defined where you can handle unprotected ESD susceptible devices or components or assemblies. And you can do that during production, repair, or field service work. One of the main goals is to provide a path to ground for the people at the workstation and also for any items placed on the work surface. I'd like to highlight in this picture that the top shelf as well as the drawer also have grounded work mats on them because any horizontal surface that you're going to put a sensitive device on should have um, a primary path to ground in a controlled way to discharge. It's more than just workbenches. Things that sometimes get overlooked are workstations where people stand, or carts, various shelves if product are taken out of the boxes. Microscope platforms are a big factor. Oftentimes they're needed to look at uh, tiny things, and the platforms should have a mat over the base. So that is also grounded because otherwise sensitive devices may be placed in an inappropriate place. Field service mats are important. Basically, any surface where um, components could be put down. Oh, I'm also going to talk about passive ESD control because that's something that may be a factor in various labs. So first, I'd like you to ask yourself, do workstations provide human body model or charge device model protection? And the definition of a human body model is that it approximates the discharge from a person to a pin on the device with other pins grounded. Charge device model approximates a discharge from a charge component to a lower potential object through a signal pin or terminal, like if it makes contact with a metal surface. Both are actually very important, and workstations can help protect both.
Ginger,
So,
we have a question,
okay,
which I think you're going to say we'll be covering most of it as we go forward. How do we verify that all ESD control elements in the workstation, grounding points, mats, wrist straps, and tools are electrically bonded and prevent charge buildup during assembly?
that's an excellent question, and I believe a lot of the slides talk about that. If it's not answered by later in the presentation, please ask it again. Thank you for highlighting that very important concept. So, one of the main things is to know how sensitive your devices are. If you have very robust or very inexpensive devices, um, they may be able, you could handle them just with using passive ESD controls. And there are effective ways to implement that. However, passive ESD controls doesn't mean no controls. Here's a engineering lab that I saw during an assessment. And as you can see, there are many, many things wrong from an ESD point of view. There's ungrounded people. There was static generating materials, metal tools. There was no compliance verification. It turned out the ESD mat wasn't grounded, but it was a beautiful blue color. They had no ESD flooring, etc. So sometimes we wonder if there is a new law of physics that engineers don't generate static. But as we all know, engineers do have a lot of potential, so they do generate static. And so, what is passive ESD protection? And it could start with a good ESD floor, and you want one that doesn't charge um, regular street shoes if you're not going to provide that. And by that I mean rubber or ESD carpet generally is low charging on a wide variety of footwear. If you have a table, put a mat down. You may have a ESD mat right at the workstation. Here's your common point ground. Let's connect everything there. As was pointed out by the question, that's very important to have everything connected. An ESD chair can be a good method of passive controls if it's an area where people are seated. And other carts can be used that are grounded. So here you have an environment where it's really hard to generate a lot of charge. And this can be 80% effective. So it's only appropriate if you have very robust components or a low volume environment. Perhaps it's an engineering prototype lab, but it's much better than nothing. So it's really good to think about setting up your environment. So in this application, the ESD controls are segregated by the level of sensitivity. Um, like I said, at research and development, there would be no products that would go to a customer or no production products. This kind of environment would work. You'd want the ESD chairs um, to have a resistance to ground close to 1 times 10 to the 6. If you start with that lower level, then as the chairs age, they will still provide passive grounding. Have all the tools, totes, mats appropriate. In this environment, there's no wrist strap or no constant monitor, which sometimes it's like a real battle to get people to wear their wrist straps. So by setting up the environment, you can get 80% of the effective control. However, if you're making production or customer units, that needs to be in an assigned ESD control workstation with the full level of production controls and monitored by the ESD compliance program. So we would start with our passive controls and we would add people with wrist straps. Perhaps design the tote boxes so that the circuit cards are perpendicular and less likely to discharge. If they were horizontal to the ground plane, they might get damaged more frequently. In this kind of sensitive components, you don't want any static generating uh, materials such as a styrofoam coffee cup. And also, if you have some essential insulators that are needed for the process, an ionizer may be needed. So, as you say, we started with the passive controls and then added uh, grounding for the personnel and remove the insulators, ionize any process essential insulators, and that is for sensitive to components or high volume situations going to a customer.
Ginger, we have another question.
Yeah,
What are the risks of relying solely on passive ESD controls in a workstation, and how are those risks mitigated?
there are risks. If this is I wouldn't compare passive controls to a full controls. I would compare passive controls to no controls. It's much better than having an environment with no ESD protection. And and it would only be used in perhaps an engineering lab or some place where they're doing prototyping and the devices are very robust and are not going to be shipped to customers. It's not appropriate for those kind of high volume or very sensitive. Often it's used in places like 911 call centers where you don't want people to get charged up and discharged to their headset or their computers. It may be used in flight traffic controlling offices where they try to keep ESD to a minimum. But it can be useful in labs, and so that's why we cover it. And um, there's not a real good way to compare the effectiveness. That's why we say it's about 80% effective, but people do charge. And if you're not going to ground your people and they're going to be touching devices, then that's not appropriate. Did that answer the question, I hope?
It was a good answer. Thank you.
So we talk about grounding. Let's start with the grounding in the area. And there's some standards there. The equipment you'd need is an ohm meter, an AC analyzer, a circuit tester, and two leads so you can check things. And it's pretty key to make sure that the wiring is done appropriately. Um, and so we've been in very high-tech, expensive to run operations where they were getting different unexplained test results, and it turned out that some of the outlets in their laboratory were not wired properly. So although this seems like you shouldn't have to think about it, it is important. Um, and the impedance of the ground conductor is called out in S2020. It should be less than 1 ohm. However, there's a new note in the latest ANSI ESD 2020 from 2021. If there's a ground fault circuit interrupter, then the impedance testing is not required, although it's highly recommended that you have your electricians check it when the wiring is done initially on the outlet. And so here's the measures to do that. Implement the power grounding connector checks. Use the power outlet receptacle as the ground. That way it's very easy to test the resistance to ground. You can plug into any AC outlet.
Okay with you?
Each grounded workbench should be connected directly to the ground bus bar, and avoid any series connections of workbenches. Here are two ways to check the facility AC ground. This yellow item in the right-hand photo just plugs in and the lights light up and tell you if it's wired correctly. It's a fairly inexpensive way to check, and it's a very good thing to do before you go around testing everything to ground. Make sure your ground is right. This circuit analyzer also has a series of tests. When you push this little arrow, it steps through various tests, and the lights will tell you when it's grounded properly. It also, as I mentioned, will test the impedance, but don't test it if you have a GFI, because you might shut down part of your facility. So once again, the note that it's not required and it may cause your ground fault circuit interrupter to activate. Verify that neutral and ground wires are not connected to each other, that the AC high and low are not reversed, and that the AC and ground wires are not reversed, and that the impedance is what your company specification requires. And if you're based on 2020, it should be less than 1 ohm, as we will see in this handy little table. So equipment grounding conductor should be less than 1 ohm impedance. Auxiliary ground, it's at some point should be connected to AC ground, and it should be less than 25 ohms to the equipment grounding connector. And if you're doing equipotential bonding, where everything at the workstation is connected to each other because there's no way to ground it, and that often happens like in a field service situation or a giant computer system that you're not really plugging it to ground, so you ground everything to that item you're working on, then every element should be less than 1 times 10 to the 9th. So here's a picture of a common point ground to the question that was answered earlier. You have that was asked earlier. You have a workstation, one place where everything's going to be connected, and then preferable connected to equipment ground. If you don't have 3-wire electrical, or for some other reason you're using auxiliary, that's a secondary way it can be done. The wrist strap connector also connected there. The work mat also connected at the same point. If you have another mat that go over a microscope, the base of a microscope, or on a top shelf, that also should be connected. So now we have, or even if you have an extra mat, and now we have an item that says each of these wires should be less than 1 ohm. So if you're going from this mat to the common point ground, that should be less than 1 ohm. The wire from the common point ground to equipment ground, less than 1 ohm. So if you can do the math, you might have 2 ohms for the whole system, but each wire is less than 1 ohm.
Ginger, you may have said it earlier. I just want to re-emphasize it if you did, and that is that the equipment ground is the preferred alternative.
Yep,
It's more cost effective and there are a lot of good reasons for it.
it's easier to do the testing too.
Yep.
You can test to any outlet. Here's some pictures of some common point ground examples, and I'm sure there's a million. Here's another common point ground. And the way you would test its connection is using an ohm meter and the two leads, and it should be less than 1 ohm. And to verify an auxiliary ground that makes sure it's bonded to AC ground, you would put the 5 pound or 2.27 kilogram weight on the table, connect it to the meter. The other side goes to power ground. It should be less than 25 ohms because you're counting on this auxiliary ground at some point being connected to AC ground. And note, each work surface should be connected directly to ground. And if the top shelves might end up with product on them, they also should have mats and be connected to the table. And then the table, each workstation should be connected directly to ground. Avoid daisy chaining or serial grounding of workbenches. The problem here is if one of these wires breaks, now you have a whole series of benches that may not be connected to ground. Now, if no grounding is available, we try to connect everything together, like equipotential bonding. One way to think of equipotential bonding is if you see a bird sitting on an electric wire, a high tension wire, that bird is connected, both legs are on the same wire, so it doesn't have any difference of electricity across its body. If it had a long leg and touched the ground, it would be in trouble. But if everything's connected together, then it's a common connection point, and if you have a work surface connected to one point, everything should be less than 1 times 10 to the ninth. And here's an example with this work mat of the wrist strap, and it's connected to the system that's being worked on. So the way you test it is put your electrode on the work mat and connect to where everything else is connected, and you should have less than 1 times 10 to the ninth. So here we have, remember we talked about the common point ground, everything's connected. Well, you get an added benefit that you have if one of the AC ground or auxiliary ground connection fails, turns out everything at your workstation is equipotential bonded. This is really important if you're working on product for a customer and it turns out somehow your ground wire came loose. You can still say all the product was protected while it was being worked on because you had equipotential bonding. It's kind of a good insurance plan. So how do you choose a mat? A lot of it has to do with what kind of work's going to be done on that workstation. You want it smooth, easy to clean, want to make sure any of the products, totes, trays, fixtures can move and work well on that mat, that you can ground it reliably. It can be tested with the equipment that you have, or if you're going to get the right equipment. Um, and functional for intended application. Some areas you may be using a soldering iron, and there are mats. I think the rubber ones generally are more resistant to burning by a soldering iron. If you're in a clean room, you have to think about outgassing as a possible problem. And what kind of, if you're going to have class 0 applications, the softer mats are better for grounding them. And remember, this workstation is grounding both the people and the devices. So that if a charged device gets placed on the mat, you want the discharge path to be slow and safe for that product. And if you have qualified several materials and you have an option for choice, I recommend getting some employees involved in the acceptance. It often highlights that they have a say in the area and they understand why different materials were chosen, and they may have a preference for color. So it's always helpful to get some buy-in when possible. And also, it's a good idea to do a trial. Set up a couple of workstations before you decide to do the whole facility and try them out. And I imagine many of you have experience doing these kinds of things. So feel free to share your feedback.
Ginger, we have another question on that slide.
Okay. Okay.
What are class 0 applications?
So class 0 is a shorthand for really sensitive devices. Generally, different groups call the sensitivity differently, but generally, if it's less than 200 volts, human body model, I guess it's 100 volts human body model and 200 charged device model, those are considered class 0. And if you're setting up a workbench, you can kind of assume you're going to end up having more sensitive devices in the future because so much more is being packed onto the chip and the circuitry's getting tinier and we want to have it faster and use less batteries and all that. They're just going to get more sensitive. So if you set it up anticipating sensitive devices, you won't have to retool later. Does that answer the question?
Yes, response was yes. I just add to it a little bit.
Yeah.
If you have components that are outside the scope of 2020, you need to take a close look at things. The countermeasures for extreme sensitivities are escalate sharply the deeper you go into the class 0 region. And as Ginger said, 2020 covers you to for CDM at 200 volts or higher, and HBM is 100 volts or higher. So it's prudent to find out what you're dealing with. Are you dealing with an egg or a football? So during the new product introduction process, strongly recommend that you require getting that data.
Yes, you could get a unpleasant surprise if suddenly very sensitive devices are going through an area that wasn't designed for it. I like that, Ted. Whether is it an egg or a football? That's a real good way to think about it.
Well, living in New England with the Patriots doing so well, we think about footballs
Yeah,
more
yeah,
than
I can
usual.
see that. Yeah. And footballs would be the kind of thing you could work on in one of those passive control areas. But if you're working on eggs, you want all of the very uh, good ESD controls.
And yeah, well beyond industry standards.
Right. So some of the other things to consider. A lot for human body connection protection, you want a solid connection. Most of the mats have a conductive layer, and that needs to be connected to ground. The dissipative surface is where the touchdown, if the part touches the surface, you want a safe touchdown, and that provides the CDM protection. And the soft mats are better, especially for lighter and small components, because it makes better contact and drains the charge off safely. Stainless steel does work for 2020 because, as Ted mentioned, 2020 has a cutoff at 100 volts um, for human body model and 200 for CDM. And some devices are more sensitive to that than that. Obviously, in clean rooms, you want something that you can clean, and stainless steel is good for that. But be aware, it does pose a CDM risk. Is that, you know, just to highlight, on a cold day, you can throw a spark to a doorknob, and that is something that your device could do if you've got metal. So one way around that is to handle the sensitive devices in a container that you could put on the stainless steel, or cover the bench with something that's appropriate for the clean room.
We have another question here. Would you say all those measurements you were describing, that the measurement cutoff uh, should be 10 to the 6 for explosives, or are you familiar with explosive guidelines?
Energetics are generally something that's not covered by the ESD Association standards. Um, I I would not consider myself an expert. I do know there are ways to reduce charging, um, and the people that implement it successfully are still alive to tell us about it. Um, I would not think that stainless steel tables is the way to go. Uh, the person that asked the question may have more experience with it than myself. I know I've seen a lot of papers, and there's some great videos about things. And by the way, here's your free survival tip. If you're ever filling your car up with gasoline and you spark a fire, leave the nozzle in the tank and run away. Don't pull the nozzle out and spray gas everywhere. The fire will go out because it runs out of oxygen. And see, ESD knowledge can save your life. But I imagine now everyone's going to get an EV and this won't be a problem. Um, oh, just some practical considerations. You don't need an ESD laminate workbench. They're expensive. If you're going to put a mat on it, just get a regular wooden workbench and add the control surface. And be aware there are different types of work surfaces, rubber, vinyl, laminates, metal, and different number of layers. It's important when you're doing qualification that you know what you're getting. Um, the ESD laminates, like I mentioned earlier, are a little hard, and so they don't make very good contact to drain charge away. And so they're not recommended for sensitive devices. Here is a picture of how to do a point-to-point measurement uh, with the two electrodes. This one is it's too high. It's 1.1 times 10 to the ninth. And remember, it's supposed to be less than 10 to the ninth. Uh, One issue with the single layer mats is they've got resistance throughout, and the distance of your electrodes away from each other can influence the measurement. So if you have this kind of mat, make sure that your resistance to ground is done from the furthest point from the ground connection, so you really know what your resistance is. And they can age out where they no longer meet the specification. This is a two-layer rubber mat, which is really good in the right side. You can see that it's 5.6 times 10 to the sixth, well within the range that is called out for 2020 as well. It's static dissipative, so it's also appropriate for very sensitive devices. Sometimes when I do assessments, we see the mats installed upside down. The bottom layer is very conductive, and this one is 1.5 times 10 to the fourth. So make sure that you understand your mat and that it's being installed appropriately. If you have a two-layer mat, the snap needs to make good contact with the conductive layer, which is often the bottom layer. A three-layer mat sometimes has a dissipative top, maybe a dissipative bottom, but there's a conductive screen or scrim in the middle. And so the snap needs to go through and make good contact with that inner layer. As we said before, serial grounding opens you up to some potential problems if one of the wires gets disconnected. So don't do this. No daisy chains. Also, sometimes people will clean up their area and put their devices in a safe spot and sometimes the paperwork and put it all underneath the mat. That is not a good idea because now it's just sitting on the laminate. So try to attach the mats to the workstation either with some kind of double stick tape or screws, something. If you attach it, you've done the human engineering to keep mistakes from happening. So there's three types of testing. Basically, qualification before you buy a bunch of the material, initial installation to make sure it's set up properly, and then the periodic ongoing compliance verification. So when you're doing qualification testing, you want to test it at a very low humidity and 50% relative humidity. You can also qualify if you know what the lowest humidity ever would happen in your facility, in a yearly basis, you can test at that humidity because I know sometimes there are places in the world where it's never going to be 12% RH. Use lab quality test equipment so you can document the values you're getting and follow the ESD S 4.1 on how to do that. For initial installation, it's good to have a standard so all the workstations are set up the same way. Verify the grounding, and then you test at specific locations. And you're going to be testing the resistance to ground and the resistance point to point in various locations. And for compliance verification, you want to test in as-is condition. Don't clean it, just move any sensitive devices out of the way. And in the dirtiest, most used part, you plunk down your 5-pound weight or 2.27 kilogram weight and test its resistance to ground because that's what your product is seeing. And here's an example of, you want to test for initial installation point to point, and usually it's in about 5 centimeters or 2 inches from the edges, just to make sure you have a good installation. So the compliance verification is considerably simpler. Like I said, you test it as is, you just move the product out of the way, and you test it to ground. And RTG is what's required for compliance verification. It's a good idea periodically to look at the resistance point to point. And also, the best test gear you have is your brain and your eyeballs. Go and check and make sure the wires are connected. Sometimes there might be another path that's grounding it from some equipment, but the mat itself isn't actually grounded. So here's a word about the continuous monitoring units. You want to set up the mat and connect it as the manufacturer says to do it. And make sure the unit is turned on. A lot of times people don't like alarms and they're very creative at turning the noise off. Validate that the monitor limits are set appropriately and visually inspect the ground wires to make sure that the connections are good. And for compliance verification, unplug the mat, see if the alarm goes off. And periodically, go ahead and test the resistance to ground. Just last week, Ted and I were doing an assessment at a facility, and we found work mats that passed the monitors but they had out-of-spec resistance to ground measurements. They were greater than 1 times 10 to the ninth. So that means the conductive layer of the mat was connected to ground, but the top surface where the devices were put down were not getting the right contact resistance. So that's something to be aware. Your mats could get worn. Sometimes they're cleaned with an inappropriate cleaner. And so it's just don't rely on the monitor for everything. And you can also use the resistance point to point for troubleshooting. And just to explain how that can be helpful, if you have a 5 pound weight or 2.27 kilogram weight, there's a conductive rubber on the bottom, and it's making contact with this dissipative layer of the mat and going through the dissipative layer to the conductive layer to ground. And that'll give you resistance to ground. If you're going between the two weights, now you're actually checking a path from the weight, through the rubber on the bottom, through the top of the mat, across the conductive layer, back up through the dissipative layer, back up through the rubber on the bottom. And so that should be higher. So if your resistance to ground is 2.5 times 10 to the 6, the RTT, or resistance point to point, should be around 5 times 10 to the 6 because it's got these extra resistances. If you find that the resistance point to point is lower than your resistance to ground, that's an indication that your ground path is not connected properly. And it's a handy troubleshooting tip. So just to do a review, and then we'll talk more about questions. If you have a well-designed grounded workstation, it's main component of the successful ESD control program. The device sensitivity is critical for knowing that you've set up the right configuration. This is not easy data to get. You have to ask for it, and it may be important to add a question about sensitivity to a new product introduction type checklist. If you don't ask for it, you won't get it. If you ask for it, you might. So it's important. And do a product qualification so you know the best materials to use. Document that. Make sure that only materials on the qualified list are purchased. There's a lot of effort to save the company money and buy something cheaper that may be the right color but does not have the same electrical properties. And verify the initial installation so you have confidence that it will meet your control program's requirements. And standardize the workstations so you can just you have confidence in every one of them. And daily visual inspections and internal audits and compliance verification are necessary to keep your control program working effectively. So I'd like to highlight the Dangelmayer website. We have videos. This webinar will be uploaded. Previous webinars will also be up there. Arnie did one on electrostatic attraction just last month. Auditing measurements will be up there. There's a lot of videos on how to do various types of measurements. And exciting coming attractions will also be on this webpage, which is at dangelmayer.com. If you can spell Dangelmayer, you can get there. Ted, did you have anything to add?
Yes, we're in the process of developing the webinar schedule for this year. And the next one will be on surface mount line assessments. We're going to give you a insight on how to test an SMT line from beginning to end. It's an interesting one, and you might want to keep an eye out for that. And we will have a workshop in July, early August. We're doing it again this year jointly with the Northeast ESD chapter. And it it will be in Nashua, New Hampshire, as we're talking at this point at BAE Systems. Good opportunity.
Oh, I also want to highlight Jeff Donahue is one of our colleagues on the team, and he's written a really good book about the SOICs and um, microchips and how they get processed. And as the thing shows, he wrote one on TSOP getting zapped. And these are good because we need our new engineers in the pipeline. This one's on thermal overload. They're all quite good. I have to say, this SOIC and SOT book, I took it home and went through it with my mom, who was 94 years old at the time. She said she finally understood what I did for a living. So it's really good. Talks about putting chips on circuit boards and how they go through their whole process. So if you've got a little engineer,
Yeah, yeah, and it's Jeff is a brilliant design expert. He has tools that most design teams don't, or many don't. So it just seemed out of character for him to do this. Not only do it, but do it so well. Anyway,
yeah,
contact Jeff, and I'm sure he'll be glad to get you.
and I think the link on our website will get to him. It's
Yeah,
Pragma Media. But he had two young daughters, and all the stuff was about programming. And he said we need people that know how to do stuff. So he was writing what really happens, but kind of get kids. And it was his books was selected as some of the top science books for Christmas presents just this last year. So.
Ginger,
Okay, do we answer all the questions? I see there's some in the chat, Ted. Let's make sure that any I
yeah,
already answered were good and they're happy, or do they have follow-ups?
no, they just like the books that you're talking about, that they should be for sale at the symposium. If you could back up to one slide, since we have a couple of minutes, I just wanted
Sure.
to add a thought.
Okay. Which one?
The one just prior to where you were, number 39. Let's see, I think that, yeah.
Yeah, I'm trying to
Um,
figure out. Oh, wait, there. Boop, 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 boop.
yeah,
There.
device sensitivity data, as Ginger said, is often hard to come by. If you go to the data sheets, more often than not, the human body model information is there, but the charge device model data is often not there. And what you might want to know is that the vast majority of failures today are best characterized by the charge device model. In fact, it's almost, it's over 99% are CDM in nature. So if you go, people have struggled with this. If you go to the supplier and ask for the JEDEC reliability report, I think it's JEDEC 42. If anybody knows, jump in. Pretty sure it's JEDEC 42. That document requires both HBM and CDM data to qualify commercially available devices. So if you ask the right question, you can find it. Uh, Going to the data sheets can be a frustrating experience. Questions? We have another couple of minutes.
Well, I really appreciate you guys starting off your new year learning about workstations. And as Ted said, we're always developing additional classes. So if there's a particular topic you'd like us to delve into in a webinar, you can put that in the chat as well. That would be helpful, or just contact um, Ted at ted@dangelmayer.com.
Yeah, we did get another question come in, and
Okay.
first of all, thanks a lot for the great talk. As you are doing many assessments, different how often are GFIs employed? And I don't know, I don't know that we've really taken a strong count of that, but it is it is a significant number that have them in the network.
Yeah, and as consultants, we're reluctant to take down a facility that we're assessing. It doesn't make us very popular. So, and I have taken down an area. We were doing some training at Ted's facility, and I did test the impedance and knock out the electrical. We had to go flip circuit breakers. So, um, it's something to keep in mind. Check with your facilities electricians and ask them. But it can be important. You know, one thing that I didn't highlight when I mentioned that the common point ground for workstations should be 1 ohm to ground. There are some companies that have metal tables and they put a 1 megohm resistor between the table and ground. That is a lot higher than one ohm. And it can be a safety issue because a GFI may not trip if it's supposed to. But if there could be high voltage on that stainless steel table and you've got the resistor in line, then it may go through the person instead of the GFI. So um, do not think you're getting a soft ground by putting a resistor in the line. The point of touchdown, when you put the metal on the metal, is where the discharge happens. That resistor is too far down the line for the discharge to be slowed down and be safe for sensitive devices. And this is a common misunderstanding. So I just wanted to bring that up. As I pointed out, you can throw a spark to a doorknob and it's not even connected to ground. So that same thing would happen on a table, even if you had a resistor.
We got a couple of notes here. Yeah, we got one comment here about same. Let's see. I'm trying to follow the. Somebody can't imagine fathom why someone would do that. I don't know if that's the GFI or what, but um, the next question is same for the device. People so often underestimate how extremely fast the CDM event is.
Yes.
It's typically a 1 nanosecond transient with rise times in picoseconds. So in fact, at those high operating speeds, or that, rapid a transient, a discrete resistor that Ginger mentioned would be invisible to a transient of that nature. Plus, the event occurs long before the path, ground to path, the path to ground can be beneficial. If you want to ask something verbally, feel free to unmute yourselves. We can do it that way as well. Down to the witching hour. We have 2 minutes left, so we're so we'd welcome, let's see.
Hi, Ted. It's Hunter Adams. How are you?
I'm good, thanks yourself.
I had a question in regards to the walking test and the new standards for that and the process for doing the walking test correctly.
Uh-huh. And what is your question?
Oh, the significance of a walking test, the 100-volt body generation on ESD flooring.
It's vitally important. It's interesting how often we find floors that will pass resistance tests, footwear that pass resistance tests. And together you get high walking voltages, which means people are charged in the area. And in one case, it was because the floor was waxed with a non-ESD wax. And I say it was faulty for walking voltages. The other thing is some people don't realize that conductive vinyl is a high charging floor unless you have good grounding footwear and carts grounded. So you tend to, the walking test helps validate that. 2020 does not require it other than for qualification, but it's prudent to do a sampling of it from time to time to make sure that what has been qualified and passes the walking tests of 100 volts and that's for 2020, scope or limit. If you have sensitivities below that, that number is not good enough. But it's really prudent to verify from time to time.
I'm really glad you brought that up. We're not walking on our workstation tables, but obviously people are part of the whole workstation. So it's vital that they're not charging. The walking voltage tests, there are some equipment that makes it pretty easy for you to do those tests. I mean, you can also engineer a solution with some meters you might have. One of the good additional benefits of doing that testing is people that think they don't generate a charge, you can show them that they do. And they can walk and it will capture the peak voltage. You can have them stand on one foot and the voltage will go up because they're not as connected to the ground as they were. And it's very good in a training situation to show it. You can also do testing of chairs by scooching around in your chair holding the walking voltage tester. So it's a relatively new measurement that's been available for the last several years, but there's getting to be more equipment that's easy to implement and do that. And the person that asked the question is because you've done it or because you want to do it or you wonder if it's important to do.
I actually do perform those kind of like on a regular basis, and I was just curious. I've gotten different readings in different areas and different test methods that we've tried with different pieces of equipment. So I just wanted to get some insight. Thank you.
Yeah, and it's very important if you're qualifying your area that you're using the footwear that people are going to be wearing in that area. Because as Ted said, you'll get different readings depending on different footwear. And if you're doing passive controls, you want to know what the maximum voltages that people might be generating using street shoes if they're not going to use ESD shoes. And some of the flooring is pretty forgiving. The rubber flooring and ESD carpet tends not to charge people up that much, even with regular street shoes. But that's adding a lot of variables. It's best if you're going to put in the money for a good ESD floor that you also have ESD footwear and that you've tested the two together as a system. And
Yeah,
once
we
you
could.
know what the peak voltages are with what you have, you can go ahead and verify that you've got the right resistance that gave you the passing reading when you qualified. But once you got the equipment in-house, it's a great training tool.
We just had another comment more than a question, talking about, walking voltage. I love it for verifying the functionality of the system as a unit, not
Yeah,
just the individual elements like the floor and the footwear.
yeah.
That way you know that they're really working together and something subtle hasn't occurred.
Excellent, excellent point.
And there are a lot of variables that can creep in with flooring, contamination, or, as I said, the wrong finish being applied and so on.
Shall the walking test be conducted when you are out of range with the resistance to ground measurement or
That
only in
would be
that case?
yeah, that would be a good idea. I, yeah, if you have failing conditions, then it'd be good to know what the risk was. How many, what are the walking voltages? Sometimes the floor will be out of resistance range and you get good walking voltages. So that would be good to know as an example.
And how you would classify this then as okay or as not okay when you do the verification assessment?
Well, if
Well,
you're
go-
following, if your ESD control program says you're meeting 2020, both will require the resistance being within the resistance and meeting the walking voltage of less than 100 volts. So if you have a different specification that you're using in your company, um, that you want to make sure you meet that. I think it's a good way to see what kind of jeopardy you might have. Have you introduced a big problem? I would think, just myself, the walking voltage is kind of more important than the resistance because the people can get charged up. But generally, you want to have all elements under control so you know you have confidence with your program.
yeah, so if I were doing an assessment, I would say, fail the resistance measurement of the floor, and then note that walking, pass the passing condition for walking voltage, which puts the whole thing in better perspective.
And I'm not sure I remember this correctly, but Ted, I remember one assessment we were doing, and they had ESD chairs, ESD floor, and a person had walked back from a break and forgot to plug their wrist strap in, and they were wondering what jeopardy had happened to the product that person handled. And we were able to use the walking voltage tester with the person sitting down and moving in the chair and show that actually a jeopardy had not happened to the product, which made them feel a lot better. Obviously, they wanted everything to be done right. You don't want to count on that. But in that particular instance, they didn't know if they needed to take corrective action immediately, and it was going to be quite expensive. So that gave them a sense of confidence that by having that additional, it's like belt and suspenders, by having that additional uh, chair in there to ground, and the person was sitting in the chair, which was connected to ground, they were providing additional protection, even though a key element of the wrist strap being plugged in had not been occurred at that point.
Another thought was shared in the comments, and that is that it's also prudent to test your walking voltages at your worst case relative humidity condition.
Yes, yes, very good. Yeah,
This
because
time of
that's what,
year, in the north, you get some really low RH levels in some
yeah.
factories.
I mean, that's when you tend to shock yourself just walking on around a house or pulling your clothes out of the dryer or something.
Hmm.
Yeah, we're testing at the worst case. In fact, I think that's part of the qualification.
Okay, excellent. Um, Again, appreciate the discussion and all the good questions. And thank you, Ginger. As usual, you did a great job. And we'll look forward to seeing you next time.
Yes.
Thank you.
All right,
Bye-bye.
Thank you, guys.
Bye.